Good morning. Today we will be discussing the properties of Laplace transform. Now we will start by discussing the linearity property of the Laplace transform, followed by the first shifting theorem, followed by the derivative of the Laplace transform, okay? Derivative of the Laplace transform, followed by the integral of the Laplace transform, the second shifting theorem, the initial value theorem, and the final value theorem. Now, I hope we can finish until the final value theorem. But if we cannot finish today, I will be continuing my lecture video the next in our next meeting. All right. Now, let's start with the linearity property of the Laplace transform. Now, like I have said before, when we say the Laplace transform of the function of t is equal to the function of s. Now, if this is the function of g of t, the Laplace transform of g of t becomes g of s. Now, if you are going to take the Laplace transform of the sum of the functions, that is equal to the Laplace transform of f of t, which is equals to f of s, plus the Laplace transform of g of t, which is equals to g of s. Now, let's have an example here. So, supposing we have Laplace, what is the Laplace transform of 2 sine of 3t? As shown here, 2 sine of 3t minus 3 times e raised to 2t. So, we are going to take the Laplace transform of two terms. Now, how are we going to do that? First, we need to take the Laplace transform of the first term, that is Laplace transform of sine t, by taking out the constant term 2 outside the Laplace transform. Since that is only a constant, you can take it out and take the Laplace transform of the function. And do the same thing with the second term. Take out negative 3 and then take the Laplace transform of e raised to 2t. If you can still recall your principles, the Laplace transform of sine bt is equals to b all over s squared plus b squared. And the Laplace transform for your exponential function is 1 minus s minus a. Therefore, if we will take the Laplace transform of sine 3t, that becomes 3 all over s squared plus 9. Multiply that to the constant term, which is 2, minus the Laplace transform of e raised to 2t is 1 over s minus 2. Multiply that by the constant term of negative 3, and that will give you 6 all over s squared plus 9 minus 3 all over s minus 2. That will be our first example. Now, let's have another theorem to discuss. Now, this time we are going to discuss the first shifting theorem. So, I'm not here to advise you to shift course, but rather to discuss what is the first shifting theorem. The first shifting theorem is defined mathematically by this term, by this equation. When we say if the function of t is multiplied by an exponential function, the Laplace transform of that is equal to Fs. But here, S is changed to S minus A. Okay? That is the first shifting theorem. Take note, A here is the amount of shift in the S domain as indicated by your exponential function here. That's your exponential function. Multiply that by f of t. Now, f of t is the function beside your exponential function. And the Laplace transform of that f of t is your f of s. Let's have an example here. Supposing I have here the Laplace transform of e raised to 3t multiplied by sine 2t. Now, if you will notice, now this is the Laplace transform of a function of t. Okay, this is your function of t. This is your function of t, and this will be your e raised to at. So in this case, 3 here is your a, and your f of t here is your sine 2t. So what are you going to do next? First, you are going to take the Laplace transform of sine 2t. The Laplace transform of sine 2t is actually your function of s. And then, what are we going to do after taking this Laplace transform? We are going to change s to s minus 3 because that is your first shifting theorem. When we say first shifting theorem, that is in the s domain, no? The value of s is shifted by a unit. So that is shifting in the s domain, or shall we say shifting in the frequency domain. So now let's try to take the Laplace transform of sine 2t. So how are we going to take the Laplace transform of sine 2t? If you can still recall, the Laplace transform of sine 2t is just 2 all over s squared plus 4. But in this case, now we are going to change s to s minus 3 as indicated here by your e raised to a t. Then, after that, after changing s to s minus 3, you will have this result. So the final answer would be what? The final answer would be 2 all over s minus 3 quantity squared plus 4. So I think no, that will be your Laplace transform of a simple function. All right. Now, we will go to our next problem. Okay, we will go to our next example, I mean. So let's have the Laplace transform of e raised to 2t multiplied by the hyperbolic cosine of 1/2, no, times t. Now, if you can still recall, no, that the Laplace transform of your function of t multiplied by e raised to at is just equal to function of s, but you are going to change s to s minus a. Let's try this problem. So what are we going to do next? If you can still recall, now we are going to take the Laplace transform of your function of t. In this case, your function of t is equals to 1/2 cosine hyperbolic 1/2 of t. So we are going to take the Laplace transform of this term. After taking the Laplace transform, we are going to change s to s minus 2. So let's try. What is the Laplace transform of hyperbolic cosine? Recall that the Laplace transform of your hyperbolic cosine, as shown in this equation above, is equals to s all over s squared minus b squared. Now, taking the Laplace transform, in that case, no, for hyperbolic cosine, that is s all over s squared minus 1/2 squared. In this, by simplifying that, it becomes 1/4. Now, after taking the Laplace transform, we need to change the value of s to s minus 2 because this is your first shifting theorem as indicated by the function of t multiplied by your e raised to at. Okay. Now, changing s will lead you to s minus 2 all over s minus 2 quantity squared plus minus 1/4. Take note, only s is changed to s minus 2. In this case, for s squared, it becomes s minus 2 quantity squared. Any questions? Oh, okay, very good. None. Okay, let's try another one. But this time, no, you are going to solve this for 3 minutes only. You can actually do this by using your brain power. Okay? For 3 minutes, I want you to solve the problem as shown on the screen. All right. Don't forget to pause your video for a while. Try to finish solving your problem here. So this is what you missed, no, from your previous video that I've shared with you, no, from YouTube. So I know you missed this type of interaction while I'm giving your lecture. You have to interact with the problems on the screen. Okay, now 3 minutes is over. Let me show you my answer. So the final answer here is s plus 5 all over s plus 5 quantity squared plus 16. Did you get it right? All right, so let's have another one. This time, no, you are going to solve this, okay, for 3 minutes only. Okay, start solving your example here. So this is example number 4. I hope you all get this right. This is not a difficult properties. No, this is actually one of the easiest property in the Laplace transform. All right, so 3 minutes is over. Okay, I will show you the answer. Oh, that is 6 all over s plus 1 raised to the power of 4. So did you get it right? Okay, I hope so. Because no, in our topic, in our class, you need to learn how to solve Laplace transform. Because Laplace transform is one of the important subject in your course. You will use this in your other subjects later on. Okay, now let's proceed with the next property that is the derivative of the Laplace transform. What do you mean the derivative of the Laplace transform? Now, if you have the function of t, as indicated here, this is your function of t, multiply that by t, the Laplace transform of that becomes the derivative of your function of t. Okay? So this is a very simple property. So all you have to do is to identify first what is your function of t. After identifying your function of t, take the Laplace transform of that. Now that becomes function of s. After taking the Laplace transform, take the derivative of the Laplace transform of your function of t. And then multiply that by negative 1. So let's try. I have here a simple problem. The Laplace transform of t multiplied by e raised to minus t. So in this problem, no, your function of t here is your e raised to negative t. That is your function of t. So you are going to plug this function to your formula here. This is your formula. And then take the Laplace transform that. Now, this is negative d over the derivative with respect to s of the Laplace transform of your function of t. Now, that becomes function of s. Now, take the Laplace transform of this. Can you still recall the Laplace transform of e raised to at? Yes, it's over here. So, recall that the Laplace transform of e raised to at is equals to 1 over s minus a. Now, if we are going to take the Laplace transform of this, that becomes 1 all over s plus 1. Now, the next thing you will do is to take the derivative of this function. So, take note of this negative. Okay. Now, in your calculus 1, you learn how to derive the derivative, how to take the derivative of the reciprocal function. That is the derivative. Now, or the derivative of the reciprocal function is simply, can you still recall? Is simply negative of 1 over u squared. Now, let me emphasize that one. The derivative, okay, the derivative, I will draw it here. No? The derivative, so, okay, I will draw the derivative. The derivative, it's not, you cannot see my drawing, so I'm sorry, no, but the derivative of 1 over u is simply negative 1 over u squared. In this case, this is 1 over u. The s plus 1 here is u. And then the derivative of your u is du, that is 1, no? All over the square of u. But you are going to multiply that by negative. So this time, if you are going to multiply negative 1 and negative, no, the result would be 1 over s plus 1 squared. I suggest you try to solve this derivative. Okay, I want to you want to solve this by taking the derivative of the Laplace transform. So I will use my laser pointer here. I suggest that you are going to take the derivative of this. This is just the derivative of the quotient. Now um, review your derivative because you will be doing derivations and integration on this subject. Okay, take note, the derivative of 1 over u is negative 1 du over u squared. Negative du over u squared. All right. Now let's take this problem. So for a while now we are going to solve the Laplace transform of this problem, t multiplied by sine 3t. So how are we going to do that? Take note, your sine 3t here is the function of t. Now take note, this is sine 3t, this is your function of t. And recall that the Laplace transform, no? The Laplace transform, this is the formula of t multiplied by the function of t is just the negative of the derivative of fs. Your fs is the Laplace transform of your ft. Your fs here is the Laplace transform of your function of t. So we are going to rewrite that in this manner. This is the negative derivative with respect to s of the Laplace transform of your sine 3t. Now recall that the Laplace transform for sine is b all over s squared plus b squared. Now, after taking the Laplace transform of sine 3t, that will give you 3, that's your b, all over s squared plus 3 squared, that becomes 9. So after taking the Laplace transform, it's time to take the derivative of the function. Take note of the derivative. This is the derivative of 1 over u. Now the derivative of 1 over u is equal to negative of du all over u squared. So in this case, your u is equal to s squared. You can actually take out 3 outside, no, the derivative operation, the derivation operation. You can take out 3 because that is just a constant. Ara ng 3, I take out 3, and what will happen here? This is just 1 over u. So the derivative of 1 over u is negative of du. Take note, this is your u, s squared plus 9 is your u, and the derivative of that is negative 2s. Take note, the derivative of this is 2, the derivative of s squared is 2s. Multiply that by negative all over u squared. Take note, you are going to square the denominator after. Okay, you are going to square the denominator as indicated by the derivative of the quotient. Next is to simplify your answer. So your answer would be 6s all over s squared plus 9. So as indicated now by the answer in front of me. Okay, now let's take another problem here, but this time you are going to solve the problem now for 5 minutes only. So take out your pen and paper now, and then solve the problem for 5 minutes only. All right. Don't forget to pause your video for a while. So pause your video and solve the problem for 5 minutes only. Okay, we're back. Now, okay, let me know if my answer is the same as yours. No? Try to comment on YouTube that your answers are all correct, no? By applying the properties of the Laplace transform. So the correct answer is s squared minus 1 all over s squared plus 1 quantity squared. Now, let's proceed to the next property of Laplace transform. But this time, we are going to take the integral of the Laplace transform. A while ago, we have discussed the derivative of the Laplace transform. So the derivative of the Laplace transform is actually uh, uh, comes from if now your function of t is multiplied by t. Uh, But this time, this is function of t divided by your t. So in this case, no, we will take the integral of the Laplace transform. Now, if your function of t is divided by t, the Laplace transform of that would be the integral, no, with limits from s to infinity of your function of s times ds. Take note, function of s here is just the Laplace transform of your function of t. Now I will just use my pointer, not my finger. No. All right, now let's try to solve this problem. So let's identify where is the function of t here. Okay, so the function of t is obvious, that is sine t. Now, plug that in your integral, in your formula. We have integral of s to infinity of the Laplace transform of sine t. Take note, f of s is just the Laplace transform of function of t. This is now your f of s. After taking the Laplace transform, it becomes 1 all over s squared plus 1. Take note, the Laplace transform of your sine function is equivalent to 1 over s plus 1 squared. Now, can you still recall your integral calculus? No. So based on the integral here, this is the integral of 1 over s squared plus 1 multiplied by ds. Can you still recall that the integral of this is arctangent? So this is simply arctangent of u plus c. But in this case, this is a definite integral with limits from s to infinity. So what are you going to do here is to uh, use the limit in solving this problem. So this is now the arctangent of s with limits from s towards infinity. So what are you going to do here is to simplify this expression. So this is just the arctangent, no, of the upper limit minus the arctangent of the lower limit. That would be the arctangent of infinity, as shown here. Oh, I'm sorry for the incorrect spelling. This is arctangent of infinity minus arctangent of s, as indicated by your limits. Now in your notes, just change this one to arctangent. No, I cannot change it anymore because I'm doing the lecture. Okay, now, and take note that the arctangent of infinity is just pi all over 2. Try to use your calculator. Take the integral, take the tangent of pi over 2, and it will give you infinity. So that, so, not so that, so the arctangent of infinity becomes pi over 2. Any questions? That will become pi over 2 all over pi over 2 minus, no, okay, minus arctangent of s. That would be the final answer. All right, now we proceed with our next example. Recall that the Laplace transform of cosine t, what is the Laplace transform of cosine t all over t? Now, if you can still recall the equation for our Laplace transform of the function of t divided by t, that is just the integral of fs ds with limits from s to infinity. Now, first you are going to identify which of these is your function of t, cosine or t. Of course, it's obvious that it is cosine. So your function of t is cosine, therefore, we are going to plug that in your integral. So that is the integral from s to infinity of your Laplace transform of cosine t. Take note, Laplace transform of your cosine t is actually your function of s. Okay, now, okay, this is your cosine t, and the Laplace transform of that is equals to s all over s squared plus 1. And also recall that this integral is actually follows this form. this integral follows this form, that is the integral of du over u. But what is lacking in your numerator if the denominator is your u? Alright, 2 is lacking in your numerator because the derivative of your denominator is 2s. So if you are going to put 2 here, you are going to balance that by putting 1/2 outside the integral sign. So that becomes 1 over 2 multiplied by, take note, this is just du over u. That becomes ln of u plus c. That's the integral, but this is the definite integral. So instead of writing c, we will just write the limits. So this is 1/2 of your ln u with limits from s towards infinity. So after substituting the limits, now it will give you 1/2 of your ln infinity minus ln of s squared plus 1. And take note, the natural logarithm or the logarithm of your infinite number is equal to infinity. So therefore, ln of infinity is infinite minus this value is still infinite times 1/2, that is still infinite. So the correct answer here is infinite. Or you may have this answer above. And I will consider it. All right. That is for our integral, the Laplace transform of integral. Now, we will proceed to the second shifting theorem. Okay. When we say second shifting theorem, this is shifted in the time domain. Take note, your time domain here is shifted by a units. In your first shifting theorem, your frequency domain is shifted by a units. That is the difference of the two. Now, recall our discussion in the unit step function. This is actually the unit step function, which is shifted by a units to the right. So that is your unit step function. Take note of the form that your function of t minus a, that is actually your function of t shifted also by a units multiplied by u sub t minus a. Take note that the amount of shift in time should be equal so that you can use this formula. If the two shifted values are not equal, you have to make it equal. So I will be discussing that on our next meeting. But for now, I will give you some problems here. So we will try to solve the Laplace transform of sine t minus pi multiplied by u sub t minus pi. So take note, the amount of shift here are equal. So that's not a problem. So if the amount of shift is equal, then we will identify what is your a as indicated here in your equation. What is your a? What is your f of t minus a, what is your f of t, and then finally what is your f of s. So let's try. Let's start by identifying a first. So in this case, based on the given Laplace transform here, a here by inspection is equal to pi, right? Okay, so since a equals to pi, your function of t minus pi, take note of this, your function of t minus pi, that is function of t minus pi, is equivalent to what? Is equivalent to this function, sine t minus pi. Alright, now if we will eliminate pi from this equation, if we are going to eliminate pi, what will happen? That becomes function of t equals sine t. Now, since you have now your function of t here, all we have to do is to take the Laplace transform so that we can have the function of s. Now, the Laplace transform of the function of t becomes function of s equals to 1 over s squared plus 1. Okay, any questions? Okay, we will proceed. Therefore, the Laplace transform of sine t minus pi multiplied by u sub t minus pi is simply e raised to negative pi s as indicated by this equation. Take note, a here is equal to the value of pi. A here is equal to the value of pi. So you just substitute the value, to your equation, and then the function of s here is actually equal to 1 over s squared plus 1. Okay, that will be your final answer. All right, this is the second shifting theorem is not that complicated. So all you have to do is identify a, your function of t, and your function of s. All right, now let's proceed to our next example. This time, we are going to find the Laplace transform of the cosine of t plus pi over 2 multiplied by u sub t plus pi over 2. So if you will notice, no, the amount of shift, of two functions are equal. So meaning to say we can directly use this equation. All you have to do is identify what is a. So let's solve the problem. So in this case, a is equals to negative 1 half. Why negative? Yes, correct. That is negative 1 half. Okay, now that is your a. Now what is your f of t plus a? Right. Your f of t plus a is this term. This is cosine t plus pi over 2. That is your f of t plus pi over 2. Now, if we will remove pi over 2 here and pi over 2 there, the result would be function of t only. The result would be function of t. Since we have the function of t, we can now solve for the function of s. Take note, the Laplace transform of your function of s, of your function of t is equal to function of s, which is s all over s squared plus 1. Now, to simplify things, now you need to plug that answer to your equation or your formula. Take note, this is e raised to minus as. Since a is negative, in this term, multiplied by negative, the result would be positive. So therefore, e now is raised to pi over 2 times s multiplied by the Laplace transform of your function of t, which is s all over s squared plus 1. Okay, I hope you've learned a lot on this lecture. Now tell me if you want more examples, and then I will be glad to create examples for everybody. Okay, happy study well. Don't forget, the goal here is for you to learn. So try to create or try to search, all the materials that will make you learn the subject more. Okay, see you next meeting.